121 as you're checking out your nails. Are they filed? All right. 121. What are your factors for 121?
10 times 11. That's all it is.
10 times 11?
No, that's not right.
Well, let's see. 10 times 11. You have, 0, 1, 0, 1. Nope, that's not going to work.
12 times 10 times.
What is it, Anthony?
Oh, give me 1 second.
Okay.
I can't do this on my head right there.
We'll work it out.
It divides by 11.
You know 11 is one of them.
Yeah, I do, but I can't.
11 times what equals 121?
I can't find the other number.
11.
2.
No,
No,
not 2, that'd be 22. It's 11. 11 times 11 equals 121. So, if you were to write this, 11 squared. What?
Man, I ain't did multiplication table in a long time. It was 21.
Come with me, folks. Let's go. All right. 11 squared times 3 will be your prime factors then for 363. All right? So any questions about this prime factorization? Because I don't want to spend too
I
much
was 11 times 11, 121.
I'm going to move on now to least common multiple, just as our quick review here. Go ahead, go out there. Okay, find the least common multiple of the given set of numbers. Least common multiple is working in the exact opposite direction as prime factorization. When you're looking to do prime factorization, you're breaking a number down into its itty-bitty little parts. When you're looking for your least multiple or least common multiple, you're taking a couple of numbers, let's say, and trying to multiply, getting bigger to figure out what's the smallest number that they would share in common. All right? So you can go about solving this in two different ways. You can take your numbers like 18, 5, and 10, and you can count by 18, 5, and 10 if you wanted to. 18, 5, 10. If we were to count by 18, 18 times 1 is 18, 18 times 2 is 36, 18, add another 18 on, where are we?
52, 54,
Add another 18,
2,
72, add another 18,
84, no, 86. No.
90, okay? And then we can count by
10,
80, 5, 10, 15, 20, 25, and da-da-da-da-da-da, and it's going to eventually get to 90, right? 20, 30, 40, and eventually you'll get to 90. And lo and behold, 90 is going to be your least common multiple for these three numbers, right?
Right.
Okay, this is form 1. You can do this with smaller numbers to do this counting business. It's fine. But the other method that you can use is doing the prime factorization. So if I took the numbers 18, 5, and 10 and do prime factorization, I'm going to break them down. So I know that 2 will go into 18 9 times. Prime. 3 can be broken, or 9 can be broken down into 3 times 3. 5 is a prime number, so it's just going to have itself and the number 1. And 10, it's going to be 2 and 5. What you can then do is look to see what are your base numbers. Meaning, how many different types of numbers are showing up here? Well, we've got a 2, and we've got some 3s, and we have some 5s. I'm not writing down 1 because anything times 1 is still of itself, so it really doesn't matter. Okay? And now looking at this, which one of these numbers has the most 2s? See, 18 has 1, 5 has none, 10 has 1. So there's just 1. There's just one, you know, it's tied. Which one of these numbers has the most 3s? And how many 3s are there? Okay, so I need to do 3 squared, okay? Which one of these numbers has the most 5s? They're
Even.
same, so we're going to leave it. Please note, I am not counting up all the 2's and counting up all the 5's and raising it to that exponent. I'm looking to see which one has the most and then writing it down. Now that I know my base numbers as well as my prime, or as well as my exponents, I can just multiply these three numbers together. I know that 3 squared is going to be 9 times 2 times 5. So I can do 2 times 9 is going to be 18 times 5 is 90. This, although it seems like it's going to be a longer step initially, once your numbers get a lot bigger, this is much faster than having to do this counting business. We're going to do a couple more like this so you guys can get a feel for it.